You're sitting on a city bus during rush hour, barely moving through a creeping stop-and-go sea of cars. The public transit bus is supposed to be the definitive answer to gridlock, but there is a glaring mechanical flaw in that plan. Your vehicle is trapped in the exact same congestion it is supposed to help you escape. Every intersection becomes a conflict zone. Turning vehicles cross the transit lanes, delivery trucks block the path, and endless waves of pedestrians compete for the same pavement. A single trip across the eastern side of Mexico City could easily consume a full hour. To make that journey faster and predictable, the city built a massive concrete viaduct high above the street. They installed elevated stations, strung continuous electrical wires, and sealed off a dedicated roadway from the chaos below. But if you look closely at this massive piece of railway-style infrastructure, there are no steel tracks. Instead of putting trains on this viaduct, Mexico City deployed fleets of blue trolleybuses. Building an expensive elevated railway and then driving rubber-tired road vehicles on it looks like a bizarre mistake. But the engineers in Mexico City were not trying to solve a bus problem. They were solving a street problem. The first section of this system, the trolleybus elevado, opened in 2022 along the Ermita-Iztapalapa corridor. The original elevated route stretches roughly 7.6 kilometers long and features 11 distinct passenger stations. A grueling one-hour journey through dense surface streets falls to roughly 20 minutes on the elevated trolleybus, not because the motors became suddenly faster, but because the obstacles that previously forced a vehicle to brake or wait have disappeared. The city engineered two distinct transportation layers. The existing street remains exactly where it is, absorbing the ordinary road traffic. Several meters directly above it, a second roadway exists for exactly one purpose: moving public transit without interruption. Mexico City has successfully operated electric trolleybuses along traditional surface streets for decades. By relying on this network, planners upgraded the running environment to an elevated corridor without acquiring entirely new vehicle technology from scratch. The result is a mechanical hybrid. The trolleybus steers with rubber tires and requires no steel rails beneath it, maintaining its road flexibility. But because the infrastructure explicitly controls boarding and completely isolates the corridor, the vehicle operates with the precision of a rapid transit railway. Mexico City spent billions of pesos on a massive acquisition of exclusive right-of-way, far beyond the cost of a traditional surface bus lane. Every concrete viaduct, station platform, and electrical system was built to support constant heavy vehicle use. Instead of loading enormous passenger blocks into a single train, the elevated busway feeds smaller clusters into a continuous stream of vehicles. The system easily absorbs 100,000 daily riders, recording over 94 million trips by its third anniversary. But that extreme frequency exposes a critical operational limit. When vehicles arrive back-to-back, one slow boarding event at a station causes a ripple effect. If multiple buses bunch together, the system risks creating a brand new type of transit congestion high above the actual street. So if capacity maxes out, why didn't they just build a train? The reality is that if passenger demand in a single corridor becomes overwhelming, heavy steel wheel rail remains the superior engineering choice for sheer volume. Mexico City's project does not attempt to prove that rubber tires beat steel rails. It proves that selecting a transit vehicle and deciding to build an entirely separated right-of-way are two independent engineering choices. After the original rollout, the city extended the elevated trolleybus eastward towards Santa Marta, creating a continuous connection that bridges the capital with the neighboring state of Mexico. This transforms an isolated viaduct into a critical link within a massive urban machine. Commuters arriving from the outer edges can step off the elevated trolleybus and immediately filter into the city's heavy metro rail lines. It also feeds directly into aerial transit nodes, moving passengers seamlessly from the elevated roadway into the suspended gondolas of the cable bus network. For the person actually sitting on the bus, transit terminology like grade separation and bus rapid transit is completely meaningless. The only thing that matters is that they need to get across town, and they are successfully bypassing a gridlocked road. This concrete viaduct functions as a multi-kilometer machine for deleting traffic lights, intersections, and street congestion from the transit corridor entirely. Mexico City constructed massive train-like infrastructure for buses because the bus technology wasn't the problem that needed solving. the chaotic traffic around it was.